Casey. I've been with Pat Clad, also known as Peterson Aluminum Corporation, for just over 10 years now. Before that, I was with another metal roofing manufacturer for about 3.5 years. And before that, I was on the contractor side of things, the metal roofing contractor side of things, where we specialized in metal roofing. We didn't really do any other types of roofing, so we concentrated on the metal side of it, which led into wall panels and soffits and anything on the exterior of the building is metal. I tell you this because I've worked with, on that side of things, anyways, I've worked with all the major manufacturers on the install side of things, know their warranties inside and out, and really helps you with these types of penetrate presentations. This is a bit of a generic presentation based around metal roofing. So we'll jump right into it. As Crystal said, you'll be getting your AA credits through AIA Florida. They take care of all of that for me. Always appreciate that. This is a copyrighted presentation. We don't mind sharing it with you. Just remember that it's should be only used for its intended use. So the course description, this is an intermediate review of metal roofing profiles, the proper applications, right? The different metal substrates that we use, the different architectural paint finishes that we use, and how they affect environmental efficiency, project sustainability, and product performance. Probably going to be talking mostly about performance, right? The environmental efficiency and sustainability, right? With metal, we're already using a ton of recycled material, and hopefully in 50, 60, 70 years, when they take the metal roof off, we'll be able to recycle it again. So some of our learning objectives, we're going to talk a little bit here in the beginning, just the history of metal and metal roofing and where it came from and how long it's been used. It's actually one of the longer used products out there. As I mentioned earlier, we're going to talk about the different profiles and the manufacturing processes for those profiles, and when and where to specify the correct product and profile to obviously obtain maximum sustainability. We're also going to talk about the different substrates that we use, right? The different metal types, the different paint finishes, and the various effects on energy efficiency and performance. And then we're going to finish up with talking about some of the common problems that we see out there with metal roofing, mainly regarding roof slope, wind loads, and installation practices. So again, just a brief history. We're going to talk a lot about the difference between structural and architectural panels. We'll talk about some wind load testing and how that relates, different materials and finishes, and then problem areas. So let's look at a little bit of the history of metal roofing and where it came from. We've actually been using metal, across the pond, I'll say, over in Europe. We've been using the coppers and zincs for just hundreds of years. You can see here in 1798 in the Massachusetts State House, put a copper roof on that was just recently replaced. This presentation's a few years old, so could have been 5 to 6, 7 years ago, but after 200 years of service life, this was copper that was installed in 1801. So some good longevity there, right? Same with zinc, right? Zinc can last a very long time. Here's a couple of little examples of that. So that's kind of where we started, right? Everything was handmade back then. Panels were made in the field, and everything was really just made by hand. And it wasn't until around 1934 where a company called Armco produced the first factory formed panel for the Chicago World's Fair. What does that mean? That means they took that flat metal, instead of bending it by hand to its intended profile, they were actually able to run it through a machine or use machinery to fabricate that metal panel. Right. Mostly back then was all these kind of exposed type fastener type panels. When these started coming out, when we were able to factory form them, that means back then, right, they probably used nails and they just drove it right through the panel. These are fairly wide panels, 2-3 foot wide type panels. We just fastened right through it with either a screw or a nail and into the substrate behind it. It wasn't until the late 60s where Butler Manufacturing produced the first concealed fastener panel, what we know now is, or we call now, is standing seam, where we don't see any of those fasteners or don't have any of those penetrations to maintenance anymore. Um, um, these days, we have a variety of different materials, profiles, and then manufacturing and installation techniques that we use. But that's a little bit of the history on it. Um, to, Today, we're going to talk about a variety of materials, profiles, manufacturing, installation techniques. Really talking about structural versus architectural type panels and what's the difference. Exposed fastener panels is what I kind of touched on. That's kind of the old way to do it. From here on out, we're not going to talk too much more about that because that's kind of yesterday's news. Still gets used a little bit on the, I shouldn't say a little bit, but on the metal building um, type roof structures, we still see some of that exposed fastener panels, but even there, at least on the roof, they're using a lot of standing seam and no exposed fasteners. So just this understanding the differences between the different profiles and manufacturing processes between structural panels versus architectural panels. The main difference is the slope that structural panels um, can be installed on much lower slopes than architectural type panels, anywhere all the way down to a 1/4 on 12 to about 3 on 12 is what they consider low slope. You're when installing these very low slope structural panels, you're passing that weight directly to the frame of the building. You're becoming part of the structural. That's why they call it a structural panel, and it's essentially a watertight panel, or also known as hydrostatic panel. May also serve as an aesthetic purpose, um, but typically up close, it's not the most aesthetically pleasing panel, right? If it's 5 stories up and you don't really see the seams in the profile, and you're just really looking at a color, that's where the aesthetic purpose can kind of come into play. We're going to talk a little bit more about that as we go through the presentation. Architectural panels, like I said, are suitable for roof slopes 3 on 12 or greater. That could change depending on the manufacturer and the profile of that architectural panel. Typically, the height of the seam, right? Some manufacturers will say 2 on 12 or greater. That 3 on 12 or greater is kind of a guideline on where most manufacturers are at. Architectural panels must be attached over a solid substrate and underlayment. The weight loads are not passed all the way to the frame. They're just passed to the decking, more of a water shedding, or also known as hydrokinetic panels. Often serves as an aesthetic purpose. That's where the other biggest difference to me, right? Architectural panels can't go as low slope as structural. Pros and cons to that, but then architectural panels are much more aesthetically pleasing than a structural type panel. Structural panels are really made more for performance than anything, to where architectural panels can still have good performance, but also have great aesthetics as well. So jumping back to structural panels, typical applications, right? Your schools, your industrial facilities, shopping centers, warehouses, prisons, government work, right? Is using a lot of these structural panels where a lot of schools, right, that are hurricane enhanced use the structural metal panels. Again, more about performance than anything. There are some instances, right, where structural panels on low slope roofs with lots of penetrations that we tend to shy away from, right? I always think of the Walmarts when I look at that roof plan. Now this is flat roofing. Thank goodness they use flat roofing material for it, but it's just skylight after skylight after skylight after skylight. So lots of penetrations in this roof may not be the best situation for metal in a low slope roof that typical structural panels are applied to. And not recommended when the roof seams are highly visible from the street or even balconies. So this is kind of what I was talking about earlier, right? A structural panel, performance-wise, can be great, but when you're able to get that close to it, and you're able, so say a 1-story building, a bank, or something like that, I typically try to shy away from these structural panels just because you get what we call clip read through in the seam, and it's just not as consistent and of a seam. But again, it's really just aesthetics. And it's not affecting the performance at all. Structural panels can be factory formed, right, in a warehouse, but they can also be formed on site with portable roll forming. So here's kind of what I'm talking about here. This is an example of a structural panel, 180-degree mechanically seamed panel, but it's not really visible from the street. It is, you can look up and you see it, but when you look up, you kind of just see the lines and you see the color. That's where the aesthetics come in, right? With structural panels, we can still play with those different colors as much as we want. But the seams aren't really visible from the street level. When somebody looks at this building, they don't look at the seam and go, it's got a little bit of an inconsistency to it, because it's far enough away where you don't really see it. Um, Here's a little bit of an example of a 180-degree mechanically seamed panel where we have the red line here is more where the hand seamers. You have to start that seaming process with hand seamers, and then you put this electrical seamer that I'll show you later. It's about 75-pound electrical seamer that you run down the panel, seaming the clips into the panel. So where not where the red line is, but the rest of the roof where you can kind of see, you can almost see like a little dent on the seam. That's where the clip is. And that's what I call clip read through. This kind of stuff, 4, 5, 6 stories up, you're not really seeing from the ground. So again, not a big deal there, but performance wise, you're getting all the performance that you need. So structural panels, again, we talked about how the load is going to the structure of the building, right? You're becoming part of that building. So open framing, right? Maybe even these metal buildings where we're using structural standing seam up on the roof, typically using bad insulation, right, over purlins or low slope metal decks with ISO insulation. Again, suitable for very low slopes, and they're designed to resist the passage of the water under hydrostatic pressure. Should be UL rated assemblies, all structural panels should be, or structural systems. Here's a little bit of a cut through of a structural type panel. This is over a wood deck, right? So just because it's a structural panel doesn't mean it just gets installed over open framing or where it needs to become part of the structure, right? This is just attaching to the decking. We, of course, are using self-adhered underlayments, high-tep underlayments, and the metal panel there. So with these structural panels, there are some initial uh, uh, higher costs upfront than say single plies, where you get your investment right. I go back to that 200-year-old metal roof that they replace, right? You get overall life cycle costs with these structural metal panels, right? We're lasting a lot longer than single ply. So you got to have the right client, right? They got to have the money upfront to pay for it, but then the return on the investment is actually much better than any other type of roofing products. That's why our government, our schools, all these industrial type facilities, they see the investment there. They see the good parts about it and end up going with metal because of the overall life cycle cost. But again, you got to have that initial higher cost being able to pay for that. Typical maintenance, I think these are pretty true with any type of roofing, right? Should you clean out your gutters annually? Yeah, I think you should do that with all types of roofing. Annual inspections by, you know, really, I say a roofer, maintenance people. I don't really want them getting up on a metal roof. I want a roofer to get up there and make sure they clean it with the right products, right? Maintenance guys can get up there and use some pretty harsh chemicals to try to clean the roof for whatever reason, right? Like I have a metal roof on my house. I live on Oak Island Road, where there's just blossoms and everything. So I do get a little bit of a molding effect on my roof where I do need to clean it every couple of years. And when cleaning these structural painted metal roofs, right, and then wash down with a very mild cleanser is all you really need. Not a whole lot of effort, or it's not a big deal to clean these roofs. So structural panels should typically always utilize a floating clip for expansion contraction reasons. I like these next couple lines where it talks about steel will expand 1 inch per 100 lineal feet given a 100-degree temperature change. Probably not super realistic, 100-degree temperature change, but this is just for round numbers. In that same scenario, aluminum will expand 2 inches. So double the amount of expansion contraction with aluminum over steel. So we just need to be thinking about that as we specify what types of materials we want to use, especially on really long runs, right? The longer the panel, the more it's going to expand and contract. So just something to think about there. Almost all these floating clips have a self-centering little tab in them. We always want to make sure that that doesn't get messed with, right? If the clip's not right in the center, if it's all the way one way or all the way the other, it's going to either only be able to expand and not contract or vice versa, right? So we want to make sure those clips are centered. Most structural panels have been tested for air infiltration, ASTM 1646, and water penetration, ASTM 1680. ASTM 1592 is a pretty basic wind uplift test. Utilizes an airbag assembly that creates a vacuum to accomplish static pressure or load. Yeah, so if your manufacturer that you're specifying doesn't have this testing, you should probably move on to a different manufacturer because that's pretty basic test in the industry. So structural panels, assembly over framing systems are frequently specified for re-roofing. So we're seeing a lot of these flat roofs, right? Want to turn into more of a sloped roof and maybe switch over to metal. Where metal does well in these applications is it doesn't weigh very much, right? When we try to go from a shingle roof, right, maybe to a tile roof, that's a big difference in weight to where metal's not, right? So the whole assembly is dependent on material used, could be any 2 pounds a square foot more using metal. So not a whole lot of added weight when you're doing a kind of retrofit type system. Here's a little bit of an example of that, where this is obviously a flat roof. They installed some red iron framing here to create a roof slope, and then we installed the metal roofing over this, what I would call open framing, right? Not your traditional open framing where it's exposed to the interior of the building, but open framing nonetheless. Pretty important here where I see on open framing and you got a hip plate here that you can see on your picture on your left. Same thing with valleys, right? We need a big valley plate in there to kind of help support the ridge caps and the trim pieces that are needed with doing this. A couple examples here on structural panels of the profiles, right? The one in the middle here is kind of the old way, the old trapezoidal system, that old Butler manufacturing, right? This is kind of what they came up with. Almost looks like an exposed fastener panel, but gives you that standing seam at the top of it, so where you can see the panel covers over the fastener, right? So no exposed fasteners. The example on the right, the 2-inch mechanical seam is typically what we see out there. That's probably your most typical profile, and those can range anywhere from 2 to 3 inches tall. The example on the left, batten cap system, is gaining popularity. I'm seeing it more in the military space, in my opinion, anyways. Right? It's not as clean of looking seam. It's a big, tall, wide, industrial type look to it, but it's gaining some popularity. I know some of the thought is when you mechanically seam a panel, right, you can never just take that apart and pop out one panel, pop in a new panel. Or some people will tell you that the batten cap system is easier to do. I disagree with that. There's caulking and seams, and you still have to kind of tear that seam apart to be able to disengage that panel system. So just some examples here, and this is where you'd probably want to call your trusted advisor and see what system you want to be using there. Here's some of that seaming equipment that I was speaking to, right? The bottom right picture is your hand seamer, where you start the seaming process so that you can engage the mechanical seamer. That's your bottom left picture. Um, doesn't look like much, but that thing's about 75 pounds and is pretty temperamental. You can see at the bottom of it, there's 4 rollers. 2 of the rollers turn that seam into what we call a 90-degree seam. So your top picture is how the panel gets installed. The profile in the middle is what we call a 90-degree seam. And then the back 2 rollers on the seaming machine will turn it into a 180-degree seam. So yeah, just some examples there of how that process is. A couple examples here of 180-degree mechanically seamed panels. Same kind of thing here. This is only 2-story. And as you can see, not super visible. You know, we can play with colors and make that aesthetic there, but not real visible and where you're going to be able to see any deficiencies in the seams. 180 degrees seamed with aluminum. This kind of was a misconception that I still tackle every once in a while, that you can't do 180-degree seam with aluminum. That was true probably 35 years ago. Now with technology and the tensile strengths and all that, we are able to do 180-degree seams with aluminum without it, cracking, grazing, which was the problem that we had before. So that is a bit of an old wives' tale these days. It's very doable. Here's a great example where we use the 180-degree mechanically seamed roof panel up top, where the pressures of the building on the 5th story, I guess that is, were much higher, obviously, than the 1-story. And out of sight, out of mind, we needed that structural performance up there, so that's what we used on top of the building. Nobody can really see that from the ground or even any of these balconies, but where you can see that lower roof from the balcony, we actually use a snap lock architectural type panel there, more for the aesthetics, and I didn't need as much pressure in my panel profile down low there than I did up high. So great example of using both. Most people, I would say, I know me and probably some of you on this webinar could maybe tell the difference between these mechanically seamed panels and architectural panels. But as you can see, kind of standing far away from the building, it all just looks kind of like vertical lines. So don't get too caught up on different profiles looking different, because to the layman, they all look up and all they see is standing seam. So switching gears a little bit to back to architectural panels. Highly visible roofs, right? Decorative elements, and when it's an integral part of the overall building aesthetics, that's when we want to shift over into architectural panels. Obviously, need that higher pitched roof to be able to do that. As you can see here, what I talked about, depending on the profile, some profiles can go all the way down to 2-on-12. Architectural panels, as a reminder, you need a solid substrate below it with underlayment. With peel and stick type underlayment, especially here in Florida, we cover the whole deck with peel and stick. So some of the typical substrates, we can do architectural panels even over metal deck, where there might be some insulation or plywood or dense deck in between. Even OSB board or Z-purlins in conjunction with rigid insulation. I've seen that as well. We've done some jobs for Disney where they wanted an ungodly amount of insulation, isoboard insulation. They wanted 10, 12 inches of it. So we installed Z-purlins. We put the insulation in between the Z-purlins, and then we attached the architectural panel to the top of that Z-purlin. That span of attachment, when you do that, though, that hat channel or that Z-purlin that you're using, we really want to get the engineer of record involved, right? You got 2 types of engineering there. You got the Z-purlin to the structure, and then you got the panel to that Z-purlin, and we need some engineering to figure out where exactly to put those Z-purlins. So just want to get that engineer of record involved early on, so we can make sure that we have all that framing in the right locations. Couple examples here, some typical architectural panel profiles. There's actually a bunch more out in the industry. The one on the far right, snap-on batten type panels, that's very low profile. Um, a bit of where standing seam kind of started on the architectural side of things. The problem with it is the uplift pressures. Typically, the lower the seam, the shorter the seam, the less pressure it can withstand. So this seam's really only about 3/4 of an inch. Once you put the batten on it, it looks like it's about 1 inch. But it's not the strongest panel in the world. The one in the middle, we don't really see that much. It's kind of an extruded clip there. Again, not real high uplift pressures. You may see a little bit of that up in the north, but not too much down here in Florida. Or typical, what you see probably 70-80% of the time out there is what we call a snap lock system, and it's the one to the far left. That's typically an inch and 3/4, it could be an inch and a half, depending on the manufacturer. Tall seam, but it snaps together. Once you snap it in place, there's no seaming involved, so that is a nice continuous looking seam all the way up the roof panel. Again, I go back into the aesthetics. Here's some examples. I really like these pictures because they show a lot of different detail, right? We have some roof pitch changes. You got some curved metal roofing on there as well. You got rake gables, you got valleys, you got almost all the details in here. And yet it's a nice, clean looking, aesthetically pleasing roof system. Another example here, just architectural panels, some different colors that we use. Even actually some metal wall panels on this one, the gray that you see there, all metal wall panels. Here's kind of a neat thing, right? We get caught up sometimes. Well, it's a roof panel, it can't be used on a wall. There's some applications when you want that vertical line look and you want a little bit of depth to it. There are some cases where we use a standing seam architectural panel on the wall. We do a lot of fire stations throughout the state of Florida where the main roof is that 2 inch tall mechanically seamed structural panel that they want to make sure, right? We get the highest pressures up there. So we want to make sure that that's good and strong. And then I have these 4 foot fascia panels, right? Where they want those seams to match up. Well, we're actually switching it up and using a snap lock on a wall, right? Imagine trying to run that seamer and hand seamers on a wall. It would be really hard to do, and then the seams would really get kind of boogered up. So we can use these architectural panels on wall systems. This is actually a flat roof, and these are just big skylights where they wrapped them in or they cladded them in standing seam architectural panels. Architectural panels always need a peel and stick type underlayment, like I said before, that you want a solid deck underneath it so that you can install these high temperature peel and stick underlayments over the entire roof surface. I know some jobs up north, they only use it in the valleys and at the eaves and stuff like that. Here in Florida, we're pretty much always covering the whole roof system, the field, the perimeters, the valleys, the ridges, everything. Typically always installed horizontally, starting at the eave, kind of shingle fashion all the way up. I have seen where it runs not vertically, I guess you could say vertically up the roof, but that's really only going to be on your really steep slopes where it's harder to install it horizontally. So it can be installed both ways, but typically horizontally. It aids with the water management, right? These architectural type panels can let a little bit of moisture and a little bit of water in them. We use the peel and stick underlayments, kind of like tile does, right? Like the tile roofing isn't what keeps the water out. It keeps most of it out, but it does let water in. We use those underlayments underneath our systems to funnel the water out down towards the eave, very similar to what the tile industry does as well. Some of your typical underlayments, your membranes, your synthetics, UDLs are out there, not typically used, but can be used. And then your high temp self-adhering membrane, right? So that self-adhering is just that. We're going to be running a lot of screws, right? Our clips to hold the panel systems down. We're running a lot of screws and penetrations right through the underlayment. We want to make sure you have a high temp, right? Because metal gets pretty hot. And then you want it to be self-adhering membrane. Here's a little bit of an example of your peel and stick type membranes. Store covered between 40 degrees and 100 degrees. We don't typically have to worry about getting below 40 degrees or installing it in really low temperatures here in Florida, thank goodness. Um, and then some of the UV exposure, right? A lot of the underlayments are um, available both in black and white, right? White typically reflecting a little bit better than the black will give you more exposure time, meaning it can be installed on these bigger jobs. It can be your roof for, anywhere from 3 to 6 months until you install the metal roofing. So some of the wind load testings, UL 90 rated roof assemblies have become prevalent in many specifications. Again, I kind of go back to if your manufacturer of choice does not have UL rated assemblies, we need to probably start looking at a different manufacturer that does, because this is pretty basic stuff in the industry. And if they don't have it, uh, you need to make sure they do, or move on to somebody else. Here's a bit of an example of the whole assembly of it, right? It's not just the roof panel, right? It's the clip, it's the fastener, it's everything involved in the system. Uh, Obviously, the clip and fastener performance is integral to overall panel performance, right? We test these panels different ways all the time, trying to get different performance out of it, right? We have panels tested with clips at 6 inches on center, and then we have panels tested at 12 inches and 2 foot on center, and so on and so on. Um, and then different size fasteners, obviously, right, with different pull out strengths and all that. We often see some projects where the specifier is not reconcile the project requirements with that of the listed construction, right? So we're not calling out what type of fastener, we're not calling out what type of clips that we need to be using. So just something to get with your trusted advisor about, make sure we're specifying the right system for the job, right? There may become times where you want an architectural panel and we may not be able to use it because it's a high wind area. So just again, something to think about. Portable roll formers are capable of producing UL 90 rated panels. It's kind of sometimes a misconception in the industry that portable roll formers cannot produce UL 90. They can. They just need to remain compliant. The panel operator must be registered by Underwriters Laboratory UL as a participant in its field follow-up program. So they basically have to re-up with UL every 6 months. Factory versus field form. You've heard me kind of talk about some of this. There's pros and cons to both. Some of the cons of producing panels in a factory environment are some of the shipping restrictions, right? 65 feet is about, I've seen longer. A typical flatbed truck is 48 foot. So that's what most panels are getting shipped on. You can do longer loads. But obviously the price of those trucks and those loads go way up. So, if you have a bank and everything is 30 foot or below, no problem making that in a factory, creating it, freighting it, shipping it out to the job site. Some of the cons where longer panels, right, is more or field forming panels is more prevalent there. You just have to be careful because your installer or whoever is running that portable machine is becoming your manufacturer. It still may be the manufacturer's material, but it's coming in coil form, and they're becoming the manufacturer of the panel system. So we just want to make sure they're compliant with the UL ratings, right? Have all the ASTM requirements that we do as factory, manufacturers. Sometimes in a factory, what can happen, and I've seen this happen, is we make them in a factory, we crate them up, we put them on a truck. Well, that truck is vibrating, it's It's driving through the elements, right? Dirt, air, wind, everything kind of gets in it. So you can get some scratches just by trying to transport it to the job site, to where if you were to roll it on the job site, field form it on the job site, right? You can kind of minimize some of that, put them right up onto the roof. Um, Again, field forming is best suited for long length applications and radius roofs, right? I always say you have to make those panels on site. There's no radius that is absolute perfect and from one end to the other. So sometimes you have to make adjustments to the radius of the panel as you make them or as you install them. So really important to do that kind of stuff on site. One thing you cannot do on site is tension leveling, and that is the picture that you see here on the bottom right hand side of the screen here. Tension leveling can prevent oil canning. It's one of the things that helps with the oil canning, and it's not possible out in the field. You can't take this machine out to the field, right, and do tension leveling out there. What does that mean? So as you can see, right, all this metal is in coil form. Metal has memory. So when you try to take it out of coil form, and you try to flatten it out, it really wants to kind of go back to coil form. It has memory. So what this machine does is it really just kind of flattens the material out, takes that camber, if you will, out of the coil and makes it nice flat material. So when it goes through the roll forming process, it's can be smoother when it goes through that process. So kind of pros and cons to everything. Um, just something to consider. Aluminum panels on the beach. I'm gonna kind of take a moment to talk about this because I see a lot of steel panels, and that includes galvanized, that includes galvalume. They are both a steel product, and when you install a steel product in a saltwater environment, doesn't have to be right on the beach, right? All these intercoastals or salt areas as well. A lot of these canals that even come off of there, some of the tributaries that come off the intercoastal, are still brackish water and still will affect steel panels. That's where we want to start switching over into aluminum, right? Pros and cons to everything. Steel is cheaper and stronger, but aluminum will last a lot longer in these harsher environments. So again, I kind of go back to that. You want these metal roof systems to last you 50, 60, 70, 80 years. We can't use steel in a saltwater environment and expect it to last that long. It will last a fraction of that time, depending on the East Coast versus West Coast, exposure, blah, blah, blah. Some of these roofs will start showing rust in 5 to 10 years. We want them to last 50 years, and it's already showing signs of rust in 5 to 10 years. So I cannot preach enough to use aluminum panels in saltwater environments. We actually really want you to take that a step further and use stainless steel accessories, meaning the clips that are underneath the panels and even the screws and fasteners that are underneath the panels. I know they're not exposed to the environment, but where we have seen failure with using aluminum panels and galvanized clips and screws is all along the eaves, all along the valleys, where maybe a little bit of moisture a little bit of blowing rain will get into those areas. They find their way out. The moisture finds its way out the same way it found its way in. But once that salt content, right, gets to that galvanized clip, it starts rusting that galvanized clip out, especially when it's kind of in a controlled, compact environment. So you might hear me talk about this more later, but I cannot stress enough about using aluminum substrates in a saltwater environment. This is just some more examples of aluminum standing seam, different colors that you can use, different applications, um, bigger jobs, smaller jobs, residential jobs versus commercial jobs. Here's an interesting one because this whole building is all made, all the exterior is all metal, obviously the metal roof. This is supposed to look kind of barn style, but even all of that, all those red wall panels, those are metal panels as well. So kind of playing with some colors here, we're able to make things look a certain way. look like a traditional wood barn with a metal roof on it, and we're actually using metal wall panels as well. Another good example of just a different color. So switching gears here, learning Jeff did number 3, identifying the different metal substrates and architectural finishes, know the various effects on energy efficiency and performance. So what type of material we're using. Um, Galvanized steel is kind of where we started, right? We have more than 75 years of architectural applications using galvanized steel, right? Also known as, a lot of the times what you hear out there is G90 is the most recommended or most used, right? But G30, G60 are out there as well. And what is that? G obviously stands for galvanized, and then the 30, 60, 90 is how much zinc is applied to that steel on both sides. So G90 is 0.45 ounces of zinc on each side of it to bring you up to 90, right? That zinc is there to help protect the steel substrate. Um, Whether it be galvanized or galvalume, 24 gauge is most commonly specified. We can do 22 gauge as well. And there's a few manufacturers out there, not very many, that can do 20 gauge as well. That zinc coating is a sacrificial element that helps enhance corrosion resistance. What happens is that zinc will dissipate over time. It's sacrificial, right? So it goes towards a scratch or it goes towards a cut edge to help protect it as long as it can, and it will dissipate over time and will end up rusting. So that's where kind of galvalume came about, where it's the same process, right? It's a coating that we put onto the steel, which is almost half zinc, but then half aluminum coating that we're putting onto the steel. So the base material is steel. We're just coating it a different way. Instead of 100% zinc, we're using a percentage, almost half aluminum coating and half zinc coating. So you have that sacrificial element that goes towards that scratch to help protect it. And then the aluminum is more of a barrier element, right? Right. Especially when you have a non-painted galvalume, where we've all been driving out in the country and seen that old barn that's just an old metal roof, but it's completely rusted red. That's because it was galvanized, right? And all the zinc is gone. And you're down to the bare steel. Galvalume helps a lot with that when it is bare, right? Because that aluminum, it's not sacrificial, right? It doesn't go towards the scratch or towards the cut edge to help protect it. It stays there and helps with that, with what I would call surface rust. Both can, accept a wide variety of paint finishes, and all the warranties available on both galvanized and galvalume. Then we have aluminum, which is superior corrosion resistance than you have with galvanized or galvalume. But then there's, like I keep saying along this presentation, there's pros and cons to everything, right? Aluminum is higher cost per square foot. And it's a little bit more volatile pricing, right? It's not as bad as coppers and zincs and all that, but it does seem to fluctuate more than steel. Does have high recycled content in it. And then I go back to that expansion contraction, right? We need to be careful when specifying aluminum roofs on really long runs because we have more expansion contraction than steel panels do. It's very easy to deal with that, right? Most times at the eave is where we deal with it. Sometimes at the ridge is where if we do a floating ridge, but we just got to give enough room for that panel to expand and contract throughout the day. Another one of the pros to aluminum, though, is the lightweight. We talked about it before, only 2 pounds, right, on a retrofit system. These are some round numbers, but 24 gauge steel. So this is just the panel, but 24 gauge steel weighs about a pound a square foot, just shy of a pound a square foot, to where aluminum is about a half a pound a square foot. So even lighter than steel here, right? Some of the most typical is 032 aluminum is the thickness. And you also see some 040 out there as well. Once you get thicker than that, right, we're not really talking about metal roofing panels. That's when we use in coat beam caps, gravel stops. The flat roofing industry uses a lot of 050 and 063. Just a little harder to form. And with roll forming, it would crack and craze. So 032 and 040 is kind of where the industry lives. So copper, right? It's as we've talked about, right? It's highly corrosive resistance. It can last a very long time. It ages to a rich patina. Um, very volatile pricing though, much higher cost than your steels and your aluminums. It's a soft metal, which requires a self-supporting underlayment. Most commonly used is 16-ounce uh, copper. You see some 20-ounce out there, but I would say the majority is 16-ounce. Now, you have a client, they can afford it, they understand the longevity, all that. I really talk about expectations here because the this chart far left, right, is when it first gets installed or before it's even exposed to any of the elements, right? Within a few months and up to a year, it really just turns brown. It's not till, depending on the environment it's in, it's not till year 5, 6, 7, even in the 10 years sometimes before you really get that green patina look that everybody's going for. So always just try to set those expectations with that building owner. I know you want that green patina look, but that's going to take 10 to 15 years for that to naturally happen, right? There are some ways that you can speed that up. Disney does some really cool stuff. With some of their stuff, trying to make it look older than it is. So there are some ways to speed it up, but just naturally, it's going to take probably 10 years for that patina look to come about. Here's a good example of that. This is the great college of FSU, Florida State University, where my oldest child goes these days. Hope we're all Florida State fans, but anyways, it's a pretty big job. This is their college of medicine building, where day one, right, they installed the copper on some walls and some roof areas, and you get that true kind of gold look to it, a very pretty look to it. But very quickly, this is after 2 years, but it probably only took about 6 months for most of this to happen. But after 2 years, you got a brown wall, right? So it's, again, not till 10, 15 years out once you drive by this building where it'll really start turning that green patina. Switching gears a little bit into some of the different paint finishes, really with metal roofing, and I specify roofing, right, when I talk about soffits or maybe even some wall applications. The PVDF Kynar / Hylar 5000 paint systems maybe aren't needed as much, but on a roof, because of the exposure, right, it's pretty much exposed. There's not too many roofs out there that are in the shade, right? So they're always exposed to the UV rays. And here in Florida, that's pretty aggressive. So I can tell you, this is a common question I get. What's the difference between Kynar 500 and Hylar 5000? Absolutely nothing. They're the exact same product, the exact same thing. There is no difference. Those are just trade names. But where these PVDF, Kynar, Hylar paints really add value, right, is the ultraviolet resistance for one. It's a soft paint in its early stages, so the formability, right? The paint doesn't microfracture like it did in the past, because it is a softer paint, and then abrasion resistance. And then resistance to airborne pollutants, right? So different chemicals in the air. It does very well with all that. But the main thing is kind of the fade rate. We're going to talk about that a little bit here soon. Its coating has a bit of a Teflon-like ingredient in it, that is really self-cleaning. More times than not, whatever dirt that gets on it just gets cleaned off with your basic rain. But it's very easy to clean. A lot of people will say Kynar is graffiti proof because you can almost clean anything off it. Again, I think I told you I have a metal roof on my house. I live on Oak Island Road with pollen and everything in the air, and I do get a little bit of black molding from time to time. That the areas where the sun doesn't hit it as much to kind of eat up that molding, if you will. I spray some water on it and I wipe it off, and it comes right off. So here's, kind of some examples of the different manufacturers out there like PPG or Sherwin-Williams or AkzoNobel and the different things that they call it. There are 1, 2, 3, and 4 coat formulations available out there. The 2 coat is considered the standard. I would say 95% of what gets installed out there is a 2 coat paint system. That basically means a primer and then your paint system on top. Every once in a while, I see these specs that call for a 3 coat paint system. I rarely see 4 coat, but I'll see especially on smaller jobs, right? Anytime I can put the first 2 coats on in one run through the paint booth, if you will. To get a 3rd coat on, I have to take it off, I have to put it back on, I have to run it through again. So you can imagine what that does price wise to the paint side of the system, right? Uh, the problem with a 3 coat that I see, the con, if you will, is you don't get any more warrantability. You don't get any advantage there is on the warranty side of things. There's nothing that says it will last longer that way, that it will hold color retention that way. I, I don't know why it's available. I feel like it's a way for the paint guys to sell more paint, but it is what it is. It's out there. So two coat is your typical. There's a very rare applications where you need a 3 coat. There's polyester type paint finishes out there. They're lower cost than the Kynar, and you get a large color range, including some of those bright colors like yellows and reds and blues. But it's the fade rate. Everything in that warranty seems to be very similar to what Kynar, but it's the fade rate that is different. The polyesters will fade much quicker than the polyester type paints. I'm not a paint guy, but the fade rate is expressed in Hunter units. The lower that Hunter unit number is, the better it is on the fade retention or fade rate, I should say. I'm sorry. So Kynar again on the roof is all I would suggest or recommend. A lot of those polyesters will tend to chalk and fade very quickly over time. You got to watch out for your prorated warranties and review those carefully. Not all warranties offer the same coverage. That's what I'm talking about, where you really want to look at the fade retention, especially on your reds and blues, right? You want to check those and make sure what the fade rate is, and if those warranties are prorated or not, may roll into what you're trying to do. So going a little bit quickly as I'm running out of time here, but some of the problem areas that we see, right? These go back to my install days where this underlayment for one is very wrinkly. It should be nice and smooth across the system. Some of that wrinkling can show through, especially on light gauge aluminum. You can see it's underneath the drip edge, right? So any moisture that gets underneath these panels when it travels down to the eave and it's supposed to find its way out at the eave, it actually goes underneath the drip edge. Think about where we have failure when we do re-roofs, right? We take off the roof and the eaves and the valleys are all rotten if it's a plywood or something like that, right? That's because we didn't install the underlayment properly. So that underlayment needs to be on top of the drip edge. Not always realistic to do. Timing wise, right? Most GCs have us come in, we dry in the building so they can keep working. Then we come back and put it on the drip edge. As you can see here, it's nailed down. You can still come across with that peel and stick underlayment and put a strip right on top of it because it's self-adhering to itself. It will allow the water to come on top of the drip edge and find its way out. Oil canning, not a cause for rejection, right? This waviness that you see in there. I am a big proponent of striations. Those are minor bends all the way through the flat of the panel. Anytime you put a bend in metal, it helps stiffen it up. So when you want those 16, 18-inch wide 032 aluminum panels, you want them smooth. You really don't, because this is what ends up being the problem here is the oil canning. And nobody Nobody likes that. They want a nice shiny penny when it's all done. I'm a big believer in oil canning is most caused by the substrate, the decking. If the decking is not true and consistent and plumb, these panels are not made to just kind of go up and down, right? They want a nice smooth surface. They want to be able to expand and contract like they're supposed to. And if you have an uneven substrate, that's not going to happen. Poorly adjusted roll forming equipment, right? That's some of the con with roll forming on the site, right? Sometimes your roofer, they bought a used $80,000 machine. They don't do the maintenance. That not fabricating, roll forming the panel properly can cause, be cause of oil canning. Overdriven fasteners, right? You see this a lot on those nail fin type panels. They overdrive the fasteners. They don't allow it to expand and contract. That's where the oil canning comes into play. So that expansion contraction is a big thing, right? If we're not moving and allowing it to expand and contract like we want it to, that's what causes oil canning. Here's an example, right? At 8 a.m., the sun's not too hot. It hasn't expanded too much, not so bad. By noon, it's all wavy and inconsistent. Here's an example of smooth panels on the left. This one's a little hard to see. You can see a little bit of the inconsistency, waviness of it. The panels to the right have striations in them. You definitely see the vertical lines going parallel to the seams, but that's what it's supposed to do, right? And it takes any of that inconsistency out of it. Corrective leveling we talked about earlier, stiffening beads / striations, right? There's kind of a good, better, best. Striations are the best. Stiffening beads are good, but not quite as good as striations. Smooth, I don't think we should be offering it at all. And then the old backer rod trick. I've had this happen where, yes, we want smooth panels. I say, no, you don't. I give them waivers. I tell them everything. Tell them it's an oil can. They don't believe me. They get halfway through the job and say, oh my goodness, we don't like it. The only fix to that, I can't put stiffening beads or striations back into the panel, but I can put backer rod underneath the panel. Helps put a bow in the panel, put a little bit of tension, and can help with oil can. Never going to take it all away, but going to help. This is a lot of stuff that we just talked about, the underlayment being installed correctly, not over-tightening the fasteners, inadequate flashing in the valleys, right? That's a big one. They don't make the valleys enough for the water out. Job site damage, job site storage, not properly stripping in the eaves that we talked about earlier on, right? Clip spacing, and not in the right areas for performance, right? UL roof systems. I'm going to go through these pretty quickly because I know Crystal's going to yell at me. Almost done. Here's a proper curb flashing, right? The one on the left is bad. One on the right is good. Never want to put a penetration right through the seam. That's a leak waiting to happen. Thank you very much. My name is Royal Casey, and here's my contact information.
Thank you so much, Royal, and you're all good.
I was going a
Um,
little fast there at the end. Sorry about that.
no worries. Well, the good thing is that a copy of your presentation is in the resources tab of your Zoom, so you can download it. It will also be provided in a follow-up email. We did have two questions. I don't know if you want to address those, or I can email them to you. Um,
Sure,
which
I can address those if you
okay.
have to.
Okay, yeah. The
Okay.
first one is there an NOA for placing the panels in a vertical position, as in the three light dormers?
Yes. So the NOA is the same, right? It's the NOA is the system and how it's attached to the building, right? So meaning it has to be the same assembly as the roof, right? If that roof is plywood with underlayment and then the panels, then that wall panel, as long as it's plywood with underlayment and then the panels, it's the same NOA that you would use for the roof that you would use on the wall.
Okay. And the second question was, is there a recommended touch-up to protect a field cut finish? Is this repair warrantable?
Yeah, good question. Good question. When we have light scratches from installation, um, that we do, most manufacturers will offer a touch-up paint, and it is a Kynar touch-up paint. The difference is that it's an air-dried Kynar, so you still get a lot of the same protectant that you would. But when we're painting a coil or a flat piece of metal, it is what we call baked on. It's heated on. So we're not able to do that with a touch-up paint. But really, what all we're trying to do is cover up that scratch, make sure that bare material is not exposed to the elements. It is matching in color, so that's nice too. But we really only want to use it sparingly. Like we offer it in 2 ounce bottles. A lot of times people will call me and say, "I need a quart of it," and I go, "Man, you need to replace some panels, right? Like it's not designed for all that. It's designed for touching up very small, minute scratches."